Hello, in this video I'm going to show you how to create mill project number 1's engineering drawing using the solid model you've already created. So the first step is we're going to go ahead and we're going to open a brand new file by going to File, New. At this point we're going to select Engineering Drawing and press OK. In order to load the IME 144 drawing template, you first must download the drawing template if you already haven't done so. If you've already downloaded it and installed it in the standard sheet formats in your computer, you can simply click on it and press OK. If you have not done this so far, go ahead and look at the Lathe Project Number 1 engineering drawing video in order to learn how to create the template and save the template properly. At this point, we have a 2D drawing template, and now we need to go ahead and insert our model views. Notice the View Layout tab allows you to insert model views by clicking on the Model View tab. At this point we're going to hit Browse and we're going to go find where we've saved our solid model. It's a good idea when managing your SOLIDWORKS files to save everything together and also label your files appropriately. Notice we're going to grab Mill Project Number 1 Giorgio.sld.prt and select Open. What this does is it allows me to now start creating orthographic projections from my part model. Now I'm going to need more than one view to describe this model. Therefore, I'm going to come over to the Model View tab and click on Create Multiple Views. Going back to the original engineering drawing we're emulating, I know that I need a front and an isometric view. The other two views are section views, and we'll create those after we place the basic orthographic views. So moving back to SOLIDWORKS, I'm going to select Front View and Pictorial View. Moving down, I'm now going to select my display style for my lines. I would like to include hidden lines in my drawing, therefore I'm going to click on the Hidden Lines Visible button. Next, I'm going to move back to my engineering drawing and look at the scale. The scale for this drawing states that it's 1/2. However, I believe it's 1:1 and that's a mistake in this drawing. We'll go ahead and create a revision of that at some point, but for this exercise, go ahead and model it at a 1:1 scale. When I hit check mark, the model views are created, and I'm able to drag my orthographic view around and my pictorial view in order to make it look very close to the drawing provided. Now notice we didn't have to model the CP and the manufacturing engineering engraving during this assignment. However, there'll be a video later on that you can watch in order to engrave your part with the CP and manufacturing engineering logo. Moving back to the SOLIDWORKS, we're going to take this pictorial view and get rid of the hidden lines in the pictorial view. Hidden lines often confuse the pictorial view and make it overcluttered. So to do that, I click on the model view and I go over to my display style for that view and I remove the hidden lines. At this point, we're ready to add other views. To do that, looking back at my engineering drawing, I see that I have two section views. I have an A and a B, denoted by the cutting planes here. So notice we have our A section and our B section. Moving back to SOLIDWORKS, we use the Section View button in the View Layout tab in order to create a section view. Section views are very simple. They look at the internal features on a part, and they use a cutting plane to cut the part on the model. So by clicking on the Section View button, I am able to create a cutting plane either vertical or horizontal. Or I could create a broken section or a section that jogs. Right now we're going to create a simple vertical section view. Now we move over towards our model with this once we select the type of cutting line, vertical, and we place it right in the middle of our pocket by selecting the midpoint relationship and clicking our mouse button. At this point, I could actually jog the line a little bit more or change where my cutting plane is going to be located on my model. If I'm satisfied with the current selection, I'm going to hit the check mark and drag the section view out to the right side of the model. Now let's say your arrows are pointing in the opposite direction. You're going to want to go ahead and hit the flip direction button, but remember the rule is the arrows point on the section we're keeping and looking at in the section view, then the section view goes on the opposite side of the arrows. So remember, the arrows always point away from the section view. So now that I've got my direction of my cutting plane correct and my section view placed, I'm going to go ahead and hit the check mark. Now there's another thing I notice on this drawing. Notice there's lines for the tangent edges on my drawing. Right here, and right here. I'm not a big fan of showing tangent edges and making them visible on a drawing. It's an optional style thing. Therefore, I'm going to right click, go to my tangent edge, and remove it. I got to do this on each view. Right click, tangent edge, removed. Right click, tangent edge, removed. What that did is it took away all the visible edges from where the fillets end, start and end. Okay, once we've placed the first section view, we're ready to select section view again and create the second section view. Looking back at the drawing, we see that B, the cutting plane, goes right through the holes, and it is a horizontal cutting plane. Therefore, when we move back to the model, I select horizontal cutting plane and I zoom in and click right in the middle of my hole. At this point, I hit check mark and I move my view above my front view. Now, looking at the drawing, the cutting plane is actually flipped downwards because the view is on top. Therefore, I'm going to hit flip direction and flip the view the appropriate direction based off the ASME Y14.5 rules. When I hit check mark, I now have created my two section views off of my front view. I'm going to go ahead and delete the labels for each section view by clicking on the label and selecting delete. It's obvious where this view comes from. Therefore, we don't need to label our section views. That is also an optional detail. Excellent. Looking at the drawing, we've placed everything in terms of views. I'm going to go ahead and delete the center marks that the drawing placed in automatically, because I want to show you how to place center marks and center lines on a drawing. Once all your views have been placed, though, we can go away from the View Layout tab to the Annotations tab, where we actually apply dimensions to our model. Now, the first thing I like to do once I have my views laid out is lay out any center lines or center marks that need to be placed on this model. Let's start with center marks. When I click on the center mark tool, I know that the document default center marks are a little large for our model. So I'm going to come over here and build my center mark size by clicking off Use Document Default and going ahead and going with a 50 thou cross mark. So now when I go ahead and I place my center line, it'll create a smaller center mark in the center. You place center marks by simply clicking on the tangent edge of the circle, and it places the center mark in the center of the circle. Actually, any edge of the circle. Now, when you have a radius, you usually place the center mark, and sometimes you remove the extended lines. So we just need to locate that radial location off of one edge. When you're finished with your center mark tool, hit the check mark. The next tool we're going to learn is center line. Center lines will go ahead and create a center line through your holes or your symmetric objects. So when I click on center line, I can actually hit select view and click on the view, and it places all the center lines for me. In fact, it placed more than I needed. There's 2 here. There's 2 here. There's 3 here. 3 here. And 3 there. That was pretty messy. Therefore, I like to place my own center lines. So an alternative method would be to click on Centerline and click on the 2 edges that you want the center line to be in between. Try to make them the same length by dragging the edges. And that looks a lot cleaner. So now that all of our center lines and our center marks are placed, we're ready to go ahead and start adding dimensions. Before we do that, let's go ahead and fill out the rest of our title block using our note annotation. The note allows you to add text anywhere on your drawing, such as 60, 61, T6, aluminum. Realize the note keeps repeating itself, so when I place it, I just simply have to type in the new name. When you're all done placing your notes, we're going to go on to linear dimensions. So our next step, we're going to go ahead and create all the dimensions. So we're going to go ahead and look at the dimensions here. We're going to first start off with the notes. Note number 3 does not need to be included on your drawing because you do not have the CP logo or manufacturing engineering on your part at the moment. Therefore, we're going to put the notes down for note number 1 and number 2. To put a note on an engineering drawing, it's very similar to the note that you put in the title block, except it's not inside the title block, it's over here on the top. So I simply go to the note tool under the annotations. I click my text box about where I'd like to place it, turn on my caps locks and write notes. All fillet radii 0.125 unless otherwise specified. What this means is every fillet on the part that we do not dimension will be 1/8 of an inch. We'll talk about that in a little bit. Looking at the second note, all chamfers 10 thou by 45 degrees unless otherwise specified. We'll go ahead and type that in as note number 2. In order to insert a symbol in a note, we go over to the side ribbon bar and we add a symbol. We hit more symbols and we look for our degree symbol. I believe that is under general symbols. They're modifying symbols. Degree, okay. Now that we're done with the note, we'll go ahead and click outside the note box, and we can place that same note a second time. To end the note tool, go ahead and press Escape. Notice I also created a second note box up here. I'm going to click on it and press Delete, and slide the note up into the top. Excellent. At this point, let's go back to our drawing, and let's look at the front view. The front view has quite a few dimensions going on. The first set that I'd like to show you is baseline dimensioning and applying these 4 dimensions with the click of 5 mouse button clicks. So if I move back to SolidWorks, Underneath Smart Dimensions, Baseline Dimension. With this tool, I can specify an origin. So the first line I click on is the baseline, or the origin. The next line, and the next line, and the next line, and the next line are the measurements I'd like to take from that origin. So when you're all done, press Escape, and we'll look at how we have a gap in between the visible line and the baseline dimension line. Next, move over here. You'll see there is a small visible gap. I'm a big fan of making it slightly larger than the stock visible gap. Also, if I move back to the drawing, you'll see that everything's a three-place dimension there. What I can do is I can move back to SOLIDWORKS, and if I want to change them all at once, I'm able to go to my Document Properties and my Dimensions and make that three-place dimensions. So now everything I place will be a three-place dimension. If I have to bring it down to a 2 decimal place dimension, I can modify it directly on the dimension. I'm going to drag this view down slightly and go back, and I'm going to place now the 2.5 and the 3.75 dimension using Smart Dimension. So moving back to SOLIDWORKS, I'm going to click on Smart Dimension. I'm going to dimension from that edge to that center mark and place the dimension. One more time, I'm going to dimension from that edge to that center mark and place the dimension. Now notice, I'd like a little bit more gap, so I'm going to pull that away. That's kind of an optional thing. Now, going back to the drawing, we're going to set our vertical dimensions using the baseline dimension. So moving back onto the view, we're going to select baseline dimension. We're going to pick our baseline, our first point, our second point, and our third point. Moving back over, we forgot to get the overall height. So therefore, our last point will be the overall height. I press Escape to end the baseline dimension tool, and I drag out the dimensions. Looking back at the drawing again, you'll see I want to create the radius 0.5 callout. To do that, I grab Smart Dimension, I click on the radius, and I drag outwards. In order to flip the arrow, we click on the button, or the little dot, right below the arrow head. That'll flip the arrow to the appropriate side, pointing at the radius through the center mark. Now when I go back to the drawing again, notice the radius is only 2 decimal points. Therefore, when I click on the radius dimension, I change the precision to 2 decimal places. Now, I'm going to use the Smart Dimension tool to dimension the diameter, the 0.201 diameter hole made with the number 7 drill. And I'm going to bring that precision down to 2 decimal places as well. Because it's a through hole, it doesn't have a depth symbol with it. Therefore, we don't need to go ahead and write THRU, because there's no depth with it. We assume that it's through. Going back to the engineering drawing, you'll see we need to now start doing our hole callouts. To do the hole callouts, we're simply going to use the hole callout tool right up here. Now I know that I've got to move that dimension upwards slightly because the first threaded hole callout, or the blind hole callout, needs to have the depth symbol. And I can shorten the horizontal jog by clicking on that, and I can change the precision of the depth over here on the right. Depth, precision, and hole precision. Now, you'll notice the drawing that I presented to you in the manual and the hole in this drawing are slightly different values. It's supposed to be a 257 drill making the hole. The first revision of the lab manual is incorrect with the 270 hole size. Either way, as long as you have a hole that's 260 or 270, you'll get full credit. Now moving back to the SOLIDWORKS model, I'm going to use the hole callout tool for the counter bore and the counter sunk holes. Now, I'm not a big fan of through all. I like to go ahead and put a depth if it's a blind hole, and if it's not a blind hole, you just put the diameter and it's assumed through. So I'm going to get rid of the through all using the dimension text on the side over here. So I'm going to go ahead and delete through, move on to this one, now I'm going to delete the through all on this one. That makes the counter bore and the countersink callouts one line callout, like we learned about in class. Now the last hole, we're going to use the hole callout to go ahead and dimension the threaded hole. Now notice this thread callout's a little incorrect because it gives you the tap drill's diameter. We don't need to know that. The manufacturing engineer gets paid very well in order to figure that out. Therefore, we're just going to put the thread callout without through all, like we learned about in lecture, quarter 20 UNC. We're almost done dimensioning this entire project. Let's go back and look at our drawing. When I look at the drawing, I see that I'm missing the radius call out here and the radius call out there in the pocket. After that, we'll move on to the section views and dimension the section views to finalize our drawing. Let's apply the radii callouts. Moving back to the model, I click on Smart Dimension, I click on the radius, and I pull out. Now, because there's 4 of these radii, I'm going to go over to my dimension text and do 4x space. Uppercase X space. Now, looking at the radii, this one is a 2 decimal place. So moving back to SOLIDWORKS, I changed the precision to 2 decimal places. Last but not least is our third radii, right over here, the 0.325 radius. I'm going to go ahead and place the dimension, click back in the dimension text and do 4x space. That completes this front view. Let's go ahead now and dimension the top section view here. Looking at the engineering drawing provided for you, we've got some linear distances, we've got some GD&T we have to add, and a chamfer dimension. Let's go ahead and start off with the chamfer, then we'll go on to the linear distances. So moving back to SOLIDWORKS, in order to apply a chamfer dimension, we're going to click on the Smart Dimensions flyout window and select Chamfer Dimension. The order of selection here is to first pick the chamfered edge and then a flat edge that I can swing the angle off of and place the chamfer dimension. Now it's time to go ahead and use Smart Dimension to size the pocket thickness, the thickness here, the overall cutout thickness, and the distance to the circular radius cutout. And we'll move that upwards and we'll go back to our drawing. So looking at the part, you'll see we've got the 1/8 inch selected, the 1.1875 dimension selected. We're just missing this 1/8 inch dimension, and then 2 depths. So we'll move back to our model. We'll go ahead and change the order that these 2 dimensions are placed, and we'll go ahead and go 4 decimal places on that one. just to show the pocket size. Might as well just do 4 decimal places on this one. And then that. Now, we're going to use the Smart Dimension tool to dimension the edge to where the protrusion starts. And we'll dimension the thickness. So if I go from there to there, we'll do 200 thou, then the overall thickness is 480 thousandths of an inch. Now, last but not least, we need to zoom in and zoom out. I'm going to drag my model view down, drag my section view down slightly, because I have to specify this bottom surface as the A datum. In order to specify a surface as a datum feature, we click on Datum Feature, we click on the edge of the part, so we pick on the view where the surface appears as an edge, we place our A datum. Notice if you had to change the label, you go over here to Label and type in the letter of the datum you wish to apply. Last but not least in this view, we're going to apply the Parallelism callout. That's done with a feature control frame through a geometric tolerance. So when I click on geometric tolerance and I select parallel 0.003, that's my tolerance, and I'm comparing that to the A datum. Before I just click check mark, I need to move the geometric tolerance box and place the geometric tolerance on the dimension I wish it to be on and press OK. Now notice it's got a leader line there. When I click on it, I want to remove the leader line and attach it just to that dimension line by dragging it out. This is the tricky part about an engineering drawing, is getting everything to fit and look good at the same time. So looking at this view, I think we're completed. Let's go back to the engineering drawing and compare. We have all the heights, the chamfer, the datum, the parallel tolerance, and the feature control frame, and all the dimensions. So now, all that's left is to dimension the height of the pocket and the height of the cutout and a few other depths here. Let's move back to our model. I'm going to drag this view over and use Smart Dimension to dimension from this line to that line, being 1/8 of an inch. Let's say I wanted to flip the dimension. I can hit the little dot on the dimension line and it flips the dimension to the other side. Next, I'm going to dimension from that edge to that edge, 1/8 of an inch. Now I'm going to dimension from that edge to that edge, 1.375. The last dimension we've got to place is this edge to that edge, the 1.625. So now when I go back to the engineering drawing and compare, you'll see it looks very much so like the example in the lab manual. Now don't fret if your holes diameters are slightly off from what this drawing says in the tutorial video. The true drill size is a 0.257, and we'll have a Rev C of this engineering drawing coming out any day. The whole idea was to understand how to model, use the hole wizard, create the hole callouts in the engineering drawing for this project, not to fret over a few thou difference in your hole size. So let's look back at the SOLIDWORKS solid model. We're going to want to go ahead and press save and save our drawing. Now remember, we want to keep the drawing in the same folder that we saved the part in. And if you can't print your drawing because you do not have SOLIDWORKS or a computer that's connected to a printer that has SOLIDWORKS on it, you could simply go File, Save As, and select PDF. What this does is it allows you to save a PDF of your project And you can go back now, and you're able to print on any computer that can open up a PDF and that's attached to a printer. So hopefully you're able to successfully create the engineering drawing. If you have any questions, stop by office hours or send your lab instructor or myself an email, and we'll be happy to answer any of the questions. Have a great day. Look forward to seeing you in more tutorials.